Inside the blood vessel, I'm going to draw in some of the cells that you'd expect to see in normal blood. So I'm going to put in a few red blood cells. I'm going to draw in a couple of platelets, which are just fragments of cells. And then I'm going to put in a few white blood cells. And even though all of these cells are found in the blood, they're actually not made there. So the cells in the blood are made inside the bone. And if you were to take a cross section of bone, so if you were to take a slice like this and you looked at it, you'd see that on the inside of bone, there's a central cavity. So this is the outside part of the bone, the hard part, and this is the central cavity. And inside that cavity, there's this red spongy tissue. And that stuff is called bone marrow. Bone marrow. And bone marrow is where all of these blood cells are made. So it's the site of hematopoiesis. So hemato means blood, and poiesis means to form or to make. So hematopoiesis is just the scary Greek word that means to make blood. So let's take a look at what goes on inside the bone marrow. So what's interesting is that as different as all of the blood cells are, they all actually originate from the same cell. And that cell is called a hematopoietic stem cell. And this stem cell gives rise to all of the different cells that you see in the blood. And so it gives rise first to two different cell lineages or two different cell groups. So first there is the myeloid group, the myeloid group, which is different from the lymphoid group, the lymphoid group. So all of the cells that you see in the blood belong to either the myeloid group or the lymphoid group. And the lymphoid group includes two different types of blood cells. So first there's the T cell, or actually that's too big because this is a very little cell. So that seems about right. So there's a T cell, and the majority of the cell is taken up by the cell's nucleus. And that's what I'm shading in over here. So much so that this cell has a nickname. It's often referred to as a naked nucleus because it looks like the nucleus isn't surrounded by very much cytoplasm. So this is a T cell or a T lymphocyte. So a T lymphocyte. And it's very similar in appearance to the other type of lymphoid cell. So this cell also has a nucleus that takes up the majority of the cell. And this cell is a B cell or a B lymphocyte. So B lymphocyte. So those are the two different types of lymphoid cells. What about the different types of myeloid cells? Well, for starters, we have a red blood cell. So I guess we should draw that in red. And this is also a very small cell. And I'm going to shade in this cell so that I can show you that the center of the cell is much lighter than the edges or the periphery of the cell. So this is not the cell's nucleus, guys, because we know that red blood cells don't have nuclei. What I'm trying to show is that the center of the cell is much lighter than the periphery of the cell. And I guess I could do a better job of that if I showed you what the cell looks like on its side. So this is what a red blood cell looks like when it's laid on its side. And it kind of looks like a dumbbell where the edges are much thicker or much wider than the center. So the edges would, since they're thicker, they would be much more densely packed with hemoglobin. And since we know that hemoglobin is what gives red blood cells a red color, the edges would then be darker than the center. And since the center is much thinner, it would have a lot less hemoglobin. And so it would be a lot paler in comparison. So we said that this is a red blood cell, but since in science we never use a plain and ordinary name of things, we call this an erythrocyte. So erythrocyte, which is just a fancy name for a plain old red blood cell. So what are some of the other types of myeloid cells? Well, we have this one cell that I'm drawing in over here. And you might say, well, that looks nothing like a cell, and you'd be totally right. This is a very odd looking, very large cell, and it's called a megakaryocyte. And even if you've never heard of a megakaryocyte before, you may have heard of what it gives rise to, because a megakaryocyte gives off little blebs of its cytoplasm to form these small cell fragments. And these fragments are known as platelets. So you may have heard of the platelets before. So the rest of the myeloid cells are actually different types of white blood cells. So for example, you have this one type of white blood cell, and the rest of these white blood cells are about twice the size of a red blood cell. So that looks like it's twice the size of a red blood cell to me. So this cell is called a monocyte. It's a monocyte. And it's known for having this nucleus that's in the shape of a kidney bean. So that kind of looks like a kidney bean to me. And this is a really cool white blood cell because it protects us from bacteria and viruses and other invading organisms, just like any other white blood cell does, but it does so in a very interesting way. So let's say that this was a bacterium, or actually, no, I like the color pink. So let's use a color I don't like. So let's say that this was a bacterium. So the monocyte would defend us against this. It would attack this bacterium by engulfing itself around the bacterium. Okay, and when it does that, it kind of looks like it's eating the bacteria. It looks like it's eating the bacterium. And so that's a very interesting way of dealing with these invading organisms. So let's clear out that. So mono actually refers to the fact that this cell has a nucleus that's in one piece. And I guess a lot of these cells have nuclei that are in one piece. But it makes us wonder what types of cells have nuclei that are not in one piece. And that would bring us to a neutrophil. So this is a neutrophil. A neutrophil. And it has a nucleus, like I'm drawing in, that is broken up into several different pieces or segments. And the segments are still held together by little pieces of string. So this is called a multi-segmented nucleus. And even if you've never heard of a neutrophil before, I'm sure you've seen them before. And how do I know that? It's because neutrophils are actually the main component of pus. So if you, like anybody else, has ever popped a pimple, you've looked at a bunch of neutrophils. So what are the other types of myeloid cells? Well, we have this one cell that's called a basophil. Basophil. And it looks something like this. You might say, well, that looks an awful lot like a monocyte, and you'd be completely correct, except this cell has a very unique feature that the monocyte doesn't have, and that is that it has these bright blue granules in its cell's cytoplasm that make it stick out. And so the way I like to think of a basophil is like a blueberry muffin, and that reminds me that it has these bright blue granules in its cell cytoplasm. So the last type of myeloid cell we talk about, So the last type of myeloid cell that we talk about is an eosinophil. So it's an eosinophil, eosinophil, okay? And it has a nucleus that can sometimes be found in two pieces. So this is the first piece and this is the second piece, but that's not what makes it so unique. What it's really well known for is the fact that it has these bright, beautiful red granules in its cell cytoplasm. So those are all of the different blood cells, with all the lymphoid cells on this side and all of the myeloid cells on this side. So it turns out that all of these cells don't directly develop from a hematopoietic stem cell. Instead, they undergo multiple stages of development to mature into their adult form. But don't worry, guys, we're not going to hash out each of those different forms and their names and physical characteristics. Instead, we're going to make a very general statement. So I guess we could put that up here. We're going to say that the immature forms of all of these cells are called blasts. And when the blasts mature, they are called cytes. And let me show you what I mean. So to spare you guys the agony of having to watch me draw out all of those different forms, I just pasted them in here. But we can see here that what we said about the immature forms being called blasts and the more mature forms being called cytes is true. So the T lymphocyte develops from a T lymphoblast, just like an erythrocyte develops from an erythroblast and a megakaryocyte develops from a megakaryoblast. So you guys get the pattern. The only wrench I'm going to throw into this pattern is with the neutrophil, basophil, and eosinophil, which all actually develop from the same cell, and that cell is called a myeloblast. So I think that that's a reasonable place to end our discussion on hematopoiesis.